All right, welcome to week 5. We're just about a third of the way through the course. Everything's to be going pretty smoothly. Actually, we're a little over the third week because it's a 14-week course and we're week 5. Okay. I'm caught up with grading. Everything is graded up until week 4. So week 5 is what I'm looking at. When that's done. Are there any questions from anyone about anything from the past 4 weeks of classes? Any questions on the quizzes, the exercises? I've been answering a lot of questions on the exercises to people who've been emailing me. Anything for you guys? Silence is consent. We move on. Okay, so this week the lesson calls for understanding how. So last week was inner joins. It was just all about inner joins. This week it's about outer joins, unions, intersects, and accepts. So union queries are very, very simple. So we'll talk about this in a second, but here, so a union operator joins two select queries that have the same amount of columns in the select statement into one results table. It does not matter at all if it's the same columns. All it matters is it has the same amount. So for example, here, I've got select last name, first name from actor, or last name like R, union, all, select last name, first name from a customer, where last name looks like R, ordered by last name. So when I run this, that's what it shows me. All the tables, just same columns, 2 columns, it's there. It doesn't tell you which one it's from or anything. If I take this back to where it said email and run this, it runs. So it's really this really weird brute force query that just takes 2 separate queries and links them into one results table. And all that matters is it is the same column count in the select part of the statement. Why would you do this? The only reason I ever came up with why you would do something like this is if you were trying to import data from different databases into a current database, or you've got 2 tables you're trying to merge into one, and you just do one select statement. That is generally one way to do it. But that's all it is. Intersect. The intersect operator is an inner join. So if you ever feel like you should use an intersect operator, just do an inner join. It's the same thing. The accept operator is interesting because up until about 8 months ago, the accept operator did not work in MySQL. So it does what it sounds like it would do. It returns except for certain things. Again, I don't talk about it here because I think there's one question on the quiz that's really easy to answer. There are no exercises on this. And up until 6 months ago, it didn't exist in MySQL. And again, 22 years in the career, and I've never used intersect or accept in any query I've ever written. So intersect joins, does an inner join, accept operator eliminates things from a query. And that's all you need to know for the quiz. Okay, so we did that. So last week we talked about inner joins. So the one thing that I don't know if I made very clear is, when you do an inner join, you want to do the join on a column that holds similar data between the 2 different tables. They don't have to be the same thing. They just have to be 2 columns that hold the same data type. And it doesn't have to make any kind of sense whatsoever. And it doesn't have to be foreign keyed. So normally when you write a a join statement on an inner join, you want to do it so that the key that it's joining on is actually a foreign key between the tables, because I don't know if we've talked about this before, but the purpose of a foreign key is to make sure that the data is consistent between the tables. I'll get that to more when I start designing a database in a little bit, and why the foreign keys are important and how they actually work. But so I have a query here. I'm selecting the last name from actor, the last name from customer, from actor, inner joining customer on last name. Last name is not a foreign keyed column. It is not an index. It's not a column they have in common, but the names are completely different. So you can do a join on any column that you want. It just has to have data that's similar enough that it would actually make a legitimate join. Because technically I can join on any, so I go here, if I go to the actor table, I could do this. So let me run this first. Okay. And I get how many results do I get? I get 43 return results, right? Oh, on a side note, someone had asked me about, they did this. Select star from film. And then they did select count from film. And this was a conversation I was having with, I don't think it was anyone, it wasn't one of you guys, was it? I don't think it was. No, okay, I didn't think so. Okay. It was a name that I didn't recognize, I don't think. So if I do select star from film, oh, F5 doesn't work here. If I do select star from film, it returns 400 rows. If I do select count from film, it says there's 1,000 rows in the table, right? And he was saying, the student was saying, he or she was saying that something about a group by and limiter and how to change that. You see this little thing up here? That limits how many rows are returned. Because if you return too many rows, it can cause network your system slowdowns. So if I do don't limit, it's going to return everything. And 1,000 rows will be returned. Anyway, that was just a sidebar thing. It was a question that had never come up before. Anywho, so I have this query here and I'm joining it on the last name and I get this really cool thing, blah, blah, blah. But here I'm going to do this. I'm going to change this to first name. Right? And it's not going to error out. It's not going to error out, but it's substantially less because there's only 10 rows where the last name equals the first name. Alan, Dean, Tracy, and Wayne. That's it, right? So when you make the joins, when you're doing your on clauses to connect the tables, it can literally be on any column that makes sense. But you have to be careful because you're not going to get the results that you want if you're not aware of what's going on. Now, if you remember when I was talking about left and right joins, if you do, so let me just do this and this, so I don't have to get the whiteboard out. Remember, I had two circles. I was doing the Venn diagram thing. There we are. Oops. All right, so I have that, and then I have that. I have that, and I have that, right? So if I do a left and right join, if I do a left join, anything in the left table, all the results, including where it's combined here, this side of it, all the red and yellow will be in the result set because it's all the red and where it matches with blue. If it doesn't match, you're gonna, so it'll return everything that's in red and only where the blue matches. If I do a right join, it's gonna be everything in blue and only where the red matches. And I'm going to show you what happens. So what happens is if I join the tables together and run the query, and the red table has 1,000 results and the blue table has 75, where the blue table responds, it ends up being null. So let me show you what that looks like real quick. So here I've got the same query I had here before. Select last name from as actor, last name is customer, from actor joining customer, where last name equals last name and ordering by last name. So here, actor is the first one, so actor is the left table. Customer is the second, so customer is the second table. So when I run this, you'll see a bunch of nulls. So Ackroyd doesn't exist in the customer table. Astaire and Bacall, Bale, Ball, Barrymore don't exist in the customer table. They only exist in the actor table. But because I said left join, I said show me everything in the actor table and only what matches in the customer table. If I do right join, it does the exact opposite. Okay. This has its uses if you want to show where something doesn't exist in the table. Like you want to run a query to see you've got a database that has customers, employees or customers and store locations, and you want to see what customers don't have a local store location. So then you would do a left join, put the customer table there and the store location on the right, and then run the query on where they lived to see who had stores near them. Does this make sense? Is everyone good on that? Samuel is nodding for everybody. Is everyone okay with that nod? All right, cool beans. That is pretty much the only code I intended to talk about tonight, because this is the only change. So last week was inner joins. This week is outer joins and unions. Next week we get into more deep coding stuff. It's all this stuff down here, but I want to talk more about design databases tonight, if that's okay with everybody. And there's one topic I want to talk about from last week about self-joining tables, why you would do that. Because one of the queries you had to do this. Select A1 dot address, comma A2 dot address from address A1, inner join address A2 on A1 dot, what was the joining thing? Was city ID, A1 city ID equals B1 city ID, A2 dot city ID. And A1 dot address doesn't equal A2 dot address. I did not spell that right. So the question was, join the address table so you can see what addresses are in the same city. But there's two different addresses. So that's what this comes out to, right? So they're talking about self-joining. Why would you join a table to itself? I've seen it done. There's usually reasons to do it. This is another good reason. So, and this is going to seem ridiculous. The only reason I ever came up with to self-join a table was I was playing with the idea of making a Pokemon database. And for those of you familiar with Pokemon, they evolve into other Pokemon. So here I've got my columns there. I've got the Pokemon ID, the name, the Pokédex value, the description, whether it evolves or not, and what it evolves into. So because they're Pokemon, but they evolve into each other, I put actually I wonder if the tables are still there. No, I deleted it. I used to have the tables here. So here, this table would join itself because I would want to know what Pokemon evolved into whatever other Pokemon. And rather than have it in a separate table, because that'd be redundant data, I just put it in here. So this evolution ID column would foreign key to the Pokemon ID, and then you would self-join on it. I don't know if that makes a lot of sense, but there are reasons to self-join tables. The whole purpose of that exercise was to explain aliasing to you and why aliases are necessary. My only problem with that conversation is aliases are always necessary. You don't just do it on self-joins. You always want to alias your table names because it saves you a lot of typing. Because whenever you're doing joins, you have to tell it specifically which table the column is coming from for clarity of purpose.
Brother Stevik.
Yep.
I think also in the code you wrote, it should be either superior or inferior, not just not equal, because you can see in your set result, you have the same line twice, but
Oh yeah,
reversed.
yeah. Yeah. So yeah, so I had duplicates there because I did the inequality. It should what it was called. So it had to be the one, not the both of them. Thanks for pointing that out, Sam. I typed it too fast. So yeah. All right. Okay, so that was last week's exercise. So any questions? We all good? Okay. So what we want to do right now is I want to talk about how databases are designed. Okay. So I'm going to go here and I'm going to create a new model. And the database I'm going to play with making tonight is going to be a database to track recipes. Okay. So I'm going to make a recipe database. Okay, so my first, let me make my first table here, and I'm gonna call this table recipe. And what do I need for recipes? I need a recipe ID. I need a name. I need ingredients. Just go with the bad spelling because I'm gonna just, I'll go back and fix spellings later. We need calories. We need servings. Serving size, no servings. We need cuisine. What cuisine is it from? Cuisine, I think that's spelled right. We need author. Who wrote the recipe? Anything else we need for this table? Name, ingredient, calories, servings, cuisine, author. I can't think of anything else.
You could do prep time.
Oh, prep time, good call. Prep time, oh yeah. Prep time. And then, oh, and then most importantly, instructions. Okay. So that's table number one. So let's look at table number one really quick. ID, every column has to have a primary key, and that's our primary key. Notice as PK and NL primary, no, this means unique. What these mean? BUN, I don't know. I forget. Binary, unsigned. Auto incremental. Okay, so we'll do auto increment there because we want that auto incrementing. And then this is generated column. We don't want to do generated column. Okay. So we need to know what it's called. Now ingredient.
Don't you want unsigned as well for the ID?
No,
Because
I don't want to, I want int. I don't want an unsigned data type.
Okay,
I want auto incremented, but I don't want an unsigned.
okay.
So it has to have a name, and then we have ingredients. So now this is where we kind of get into the first thing. How many ingredients does a recipe have? Quite a few, right? And we can't, I mean, and this is, so what I see a lot of people do, like ingredient 1, ingredient 2, ingredient 3, ingredient 4, ingredient 5. The problem with that is, we don't know how many ingredients it is. And so let's say we've got 30, got a chat here. Oh yeah, cook time ingredient, yep. Thanks for the correct spelling, let me fix that. Paste, okay. Cook time, website, let's do cook time, we'll add cook time to that, like that. Copy. I'm at here, paste. Okay. Website link, we'll hold on to that later, or book something. Yeah. I'm going to assume that these are all original recipes because we're that awesome. Okay. So we don't want to do ingredient 1, ingredient 2, ingredient 3. That's not going to work. So we're going to go here and we're going to make this the ingredient table. Nope. And we'll have ingredient ID and then name. And then we'll have, oh, what else we have there? Just leave that there. Okay. Just ingredient name and in. So now, because one recipe has many ingredients and one ingredient will have many recipes, we can go ahead and go down to here and grab this little guy and make this table. So ingredient recipe has ingredients. Okay. I'm going to add here. I'm going to see if this works. I'm not sure if this is going to work. So I'm going to do calories here. Okay. Because each ingredient is going to have its own calories, or make that an int. And it's going to be calories per serving. Oh. So real quick, I'm going to do a real quick tangent here. So in the world so if we go here and I go to my numbers, you'll see I've got big int, I've got small int, I've got tiny int, and I've got int. So the difference is, so let me pull up Notepad here. Okay, so I've got tiny int, I've got tiny int, I've got small int, I've got int, and I've got big int. And you know the difference between them? So tiny int I think is 8 bits. Small int is 16. Int is 32 bits and big int is 64 bits. So what that means is each row in each column that this data type is in will take up that much space. Okay, so when we look at this table, each row is going to take up X amount of space, right? And the int is going to take up 32 bits of space on your hard drive, saved on your hard drive or on your in your RAM, right? Tiny int, I'm going to be off on my numbers, but this is roughly it. It's negative 256 to positive 256. This is negative 16K to positive 16K. This int is something like 2 million, negative 2 million to positive 2 million. And then this is just ridiculous numbers. This is like, 64 billion to negative 64 billion to positive 64. Something like that. I'm not really sure on the numbers, but that's roughly what they are. Okay. So that means if I have a column that the number is going to be really, really small, I'll use tiny int in that field. I won't use int. If that number is never going to go over 256, then putting int there as the ID column data type is just too big. It's too much, right? Because think about it. Let's say this is amazing. Everyone loves this database, and I make my and I have my serving size. Where is that serving size? So here, my serving size here, which would probably be an int. So change that to an int here, right? Come here. So servings, I have it as an int, right? But it's never going to be, hush. It's never going to be more than like 6, right? So this is taking up 64 bits of space every row, and when it could be taking up 8 or 32 bits of every, it's going to take up 32 bits every row instead of 8. So if this table is 1 million rows long, this is taking up 4 times the amount of space that it needs to be. Does that make sense? That the implications behind that? Why you need to choose the right data type? You've always, whenever you're designing a database, you've always got to plan ahead. You've always got to assume. Yeah, exactly. It's like double versus long versus char, exactly. And again, double versus long, you got to choose the right one because it takes up space. And char versus varchar, again, it's about how much space you're taking up because you've got to plan ahead. So this company I worked for a long time ago was a title insurance company, and they had this huge database because what they did is they went to every state in the union and got all their property records, and they coalesced them into one database, and each county had its own database, and that was fine. But they had one specific database that captured the transactions of each customer. Okay, so anytime someone did a search, it was captured in this table, and they were charged for it, blah blah blah, right? So they built the table when the company started 5 years prior, and they did it with their ID being an int, which stopped around I think it's 2 million or something like that. And they're like, that'll be fine. We're never going to reach 2 million, right? 5 years later, and they're at 1.9 million rows, right? They now all of a sudden have to change the data type from int to big int. And that's literally doubling the size of that column because you're going from 32-bit to 64-bit. So you're literally doubling the size of that column. So not only is it going to take a long time, because it's almost 2 million rows, you're increasing the size it takes up on the disk, right? So planning ahead with your data types is hyper critical. You've got to be very, very careful in what you choose. So that's so with int, big int, long, all your numeric, they take up a defined amount of space. And int will always take up 32 bits. Okay. When you're looking at char and varchar,
Sorry, I had a quick question about that example you just gave.
sure.
Is it complicated to change the database once like, for example, for this company, apart from the space it took, like, is there a cost like
It
to
would
it?
so yes, there was a significant cost. The database was down for 2 days. They couldn't
Okay.
they had it the database was down for 2 days. They couldn't make money for 2 days. They had to buy, I think it was something like $3.5 million in storage. So yeah, it was a significant cost. Now, no one was mad about it because it was one of those embarrassments. We never thought we were going to be this successful, right? But as you, I mean, and for the most part, these database design that you guys are doing are, some of you are like taking it very seriously. You've got a family or a friend that needs a database, and you're designing it for them. So when you're designing the database, you're thinking to yourself, is this going to be for more than just plus minus? Oh, thank you. Okay, it's 128. What did I say? 256. Okay, so I was off. Yeah, so 128. Okay, I knew my numbers were off. Thanks, Nathan. Okay, so yeah, so the 64-bit is 9 quintillion. I knew it was a ridiculously high number, which means I think this is 2 billion then probably, but whatever it is. So whatever it is, it's just, that's how the numbers. So just understand that's how the numbers work there, right? So your integer based numbers are defined specific amounts. An int will always be that size. A big int will always be that size. When you're looking at char versus varchar, so you have char 12 and varchar 12. The difference between these two is that if you do char 12, it will always take up 12 spaces. If I made this, cuisine char 12, no matter how big the word is, it will be 12. And if I try to put over 12 characters in it, it's going to say you can't do it. Okay. When I say varchar 12, that means it only takes up the amount of space that you put into it. So if this was varchar 256 and I put in 12 characters, it would only take up space of 12 characters, but it would allow up to 256. It's variable character. So you want to make sure that you account for these spaces and stuff like that, right? So when you're going through your database and doing this stuff, make sure you're choosing your data types. There's I'll try and find it for you. I did a video like 5 or 6 or 7 years ago about like a deep dive into data types. So anyway, so yeah, so there's that. So calories per serving, int is probably too big, so we can go make that probably tiny int's too small, int's too small, so tiny small, so small int. That'll work. Okay, cuisine, blah blah blah. Okay, so ingredients. Servings will be tiny int because we're not doing thousands of servings. Okay. So here I've got ingredients, I've got calories per serving. That's not going to work there. I gotta figure out how that's going to work. So let's take that off of there for right now. Delete. You're also going to notice I talk to myself a lot while I do this, but that's the process while you're thinking through this. So here I've got recipe for ingredients. I've got the recipe ID and I've got the ingredient ID, but I don't have the measurement needed. So what I need to do is I need to put a column in here called measurement. And then I need a column or to say what kind of measurement, because is it a cup? Is it a teaspoon? Is it a liter? Wrong one, wrong table. Delete there. Delete here. Okay. So get this table here. So get this table. There we are. So here I want measurement. And this I'm going to make a float. And then a measurement type. Okay. So with measurement type, it could be cups, it could be liters, it could be teaspoons, tablespoons, whatever it's going to be. So I would like, recipe ID 1, ingredient ID 6, measurement 5, and then make this tablespoons. Now, when we talk about normalization of data, there's a couple different layers to it. And the one layer is to make sure there's no duplicate data anywhere. So whatever this table's title is, whatever's in here makes sense to what the table says. So does it have to have this? Does this column match directly back to recipe? Okay. So name, yes. Ingredient, yeah. Ingredients, which is now we got to take that column out because now it's ingredient. That guy's got to go. So ingredient has to go because we made that separate table, right? Okay, so we'll look through there, right? Now, the other reason why we want to make sure with data normalization is we want to make sure that data gets input correctly as well, right? So imagine yourself inputting a recipe and you're putting in the ingredients and you type in 5 tablespoons of one thing, but in the second one you do 5 tablespoons, but you misspelled tablespoons, right? So because you have this opportunity for human error in data input, we want to make sure we minimize that by making the physical data, the physical act of inputting data as minimal as possible. So you've all been to websites where there's drop-down boxes, right? So whenever you're inputting data in a database, we think in terms of the front end and saying, we want to make sure everything is consistent. So I'm going to create a new table here. And I'm going to call this measurement type. Okay. And then I'm going to connect this here. And now we're going to go into common mistake number 2 in doing this. So here, I'm going to put cup. And then next, I'm going to put tablespoon. And next, I'm going to put teaspoon. And next, I'm going to put ounce. So you see what I'm doing is I'm creating a column for each type of measurement there is. Okay. And this is not the correct way to do it. Whenever we have a situation we're doing something like this and we have a bunch of different options underneath here, we want to make sure that if we need to add another option, it doesn't require us to change the structure of the table, right? Because changing the structure of the table is a schema change, and that's complicated. So let's say I just use these 4, and then I've got the database is in operation for 6 months, and all of a sudden someone says we got a recipe that uses pounds instead of uses pounds. So we've got to go back here, we've got to add a new column, call it pounds, adjust everything, change all the indexes, change all the structures. So instead of all this, we're just gonna put a name column here, okay? And in there, we have ID 1, cup, ID 2, teaspoon, ID 3, tablespoon. That way, if we have to add a new measurement type, we're just adding a value to a table and it's populating to the drop-down menu on the front end, right? So what we're doing is we're making sure that the data is staying clean. So I'm going to go here and I'm going to delete measurement type. And then I'm going to do a one-to-many relationship. And I did it the wrong way. There we are. So now we have the measurement type here. So it's the drop down here, okay? But it's coming from this table and I'm foreign keying that. Okay. And again, the reason is to keep the data consistent. So there's gonna be a drop down menu that someone's filling out and not something that, you know, Bob from data entry misspelled cup today. And so there's a new measurement called CPU. Now, the other thing that foreign keys protects against is another. So phase 1 of normalization is making sure there's no redundant data. Phase 2 of normalization is making sure that we've got clean data entry through drop-down menus and we're controlling what values can be here. Phase 3 of normalization or data consistency, I shouldn't say normalization, data consistency is to make sure that the reason we do foreign keys is no one can enter a measurement that doesn't exist from this table. So if you have the drop-down menu, someone try to type one in, it wouldn't go there because if it's not here, it can't be here. Okay, this is built-in protection that if I don't have the measurement type here, it can't exist here. And if I delete it from here, it's not going to let me because it exists here. So I can't have someone coming in and suddenly decide, I think, you know, tablespoon and recipe is stupid. So I'm going to make sure there's no tablespoon recipe, go and delete it. So this foreign key protects the data. And I think here's where I'm going to put calorie. I think here's where I'm going to put calories because that makes the most sense. Because each ingredient has a calorie to it. And that's going to be, that's probably going to be small int because that could be in the thousands. Yeah. And then over here, I don't have. Okay. Everyone with me so far? Is this making sense? Okay. Everyone give me like what can I do here? Do we have like some emojis that we can like say, hey, give me a thumbs up? Yeah. If everyone just like give me like some kind of nod that everyone following along here. There we go. That's what I'm looking for. Camilla's got it. Good. All right, cool beans. Let's see, calories, or we put that in the recipe here, so we don't need that anymore, so that can go away. Because now the rest, so then we would write a query that gave me all the calories based on here. So I just do a sum of the calories through a join query here. Servings, that can say their cuisine. One dish could have multiple cuisines or not, but either way, we want to make sure we have data integrity. So we're going to make a cuisine table. And we're going to do the same thing we did over here. We're going to do this. We're going to call it cuisine. We're going to do cuisine, and we're going to do an ID. We're going to do a name. Okay, and then I'm going to foreign key this Did it backwards again. Gonna foreign key this. I don't want to join itself. Okay. Okay, and then I'm going to go here. And I'm going to delete cuisine from there. Delete. All right. So we're going to there. And again, we don't want to do a column for each cuisine because we might add a cuisine. All of a sudden we've got Ethiopian cuisine, or we've got different kinds of cuisine we're adding to our recipe book. Author. Could one author can there possibly be two authors to one recipe? Yeah, there could technically be. Also, we want to make sure we got data consistency, so we want to make an author table. And then we'll go ahead and I'm not going to go into a lot. We're going to do an author ID. We're going to do a last name. First name. Okay. Is it possible that two people may have wrote a recipe? Is it possible that two people create a recipe together? Absolutely. So we're going to go ahead and do one of these tables. So now one recipe can have multiple authors. And go back to our recipe table and we get rid of the author column. Okay. Prep time, that stays there, but we're going to change that data type to a tiny int because it's not going to be over 128 minutes, hopefully. Cook time, we're going to change that to a tiny int. And then instructions, this is just probably gonna be a big old text field. Because it's just gonna be a large, is text still a thing here? Yeah. Yeah, you didn't like that. And what text means, it just can be as big as it needs to be. So that, I think that's probably the best thing. We're not gonna do it as a separate table. That seems to be a bit excessive. You could do it as a separate table, but I don't know. That's that. You can play with it. Yeah.
Well, I'm guessing most likely you'd probably have it like as a an address to some kind of XML or text file or whatever, instead of actually being stored in the database.
You could, I mean, you could do any number. You can store XML in the database. And format it that way. So there's any number of ways you can do it. You could have it store you won't. Yeah, this is the part I hadn't really fully thought through when I was doing it. I wasn't sure how I'd have the recipe, the actual instructions in there. You could do it as a table and have the instructions in there as a row in each table and have link it over. You could do it as an XML because XML, I don't know if XML is a data type here. In Oracle and in SQL Server, XML is a data type. So you could do it in XML within the table itself. And so you'd have that out. But I've got horror stories about putting XML into a table. You could do it as a PDF. Any number of ways of doing it. It's all, that'd be dealer's choice on how you'd want to do it. I haven't really thought that part out because I kind of been playing with this idea for the last week on how I do it, and I was kind of struggling on how to get the instructions in there. So it would have to be formatted correctly so people could see it. Probably putting it its own. Let's see what that would look like. Let's see. Let's see what that would entail. Let's see. And then do an instruction ID and then step. And do a step. So then you would want to foreign key. No, what would we do this? We go that way. I think we would do this. I got it backwards again. I think we would do. No. Yeah, I think we would do that. I think that could work. So here I'd have the instruction ID, what the step was, and the recipe was attached to. That might work. Yeah, I could see. And then you could format it really nicely on the front end when you pull that out. Yeah, I think that'd work. I think that's good for right now. Yeah. Cook time, 10 instruction. That would mean this would go away here. And where'd that go? Instruction, go away. Yeah. So when you're designing, you go through this, I mean, you would take this and you'd look it over probably the course of a week to massage it, to make sure it's right. And you check how the data flows. Is everything flowing right? You know, how are we getting together? And this is where you start looking at your test cases when you're trying to prove it, right? So you're like, you know, I might have a test case. Show me every Moroccan recipe that uses chicken. Show me a French meal with pork that I can make in 25 minutes or less. Show me a Southern meal that is less than 500 calories per serving. Right? Does that mean, is this making sense to everybody? Is everyone following along with this?
Yeah, it makes sense to me.
Yeah. But that's how and you saw I started with the one table and I said, here's everything I need to know about recipes. And then, well, that really wouldn't be in this, it'll be in a different table. I need a join table here. I need a bridging table here. I would put measurements over here because I want to keep data consistency. I don't want people typing in the measurement type. I want that locked in so they can't do that. I want author information, you know. So this kind of and this is 1, 2, it's 1, 2, 3, 4, 5, 6, 7, 8. And this falls, so you want your final project needs to be between 8 to 10 tables. Right, this falls right in there, and I keep that as the benchmark for 8 to 10. I find that when you're designing databases, once you hit 10 tables, you usually hit 14 right after that. There's not like 11, because everything sort of compounds on everything else, right? But I think, yeah, I think this is solid for right now. It's definitely not perfect by any stretch of the imagination, but this is a good start to this, right? And then what I would do is I would set aside this, I'd go do something else for a couple hours, come back and look at it again to make sure that it makes sense. Like, is this really where I want to put calories? Does it make sense to have instructions in a separate table, or do I want to do it a different way? Yeah. Is this, do I really want to float data type for measurement, or do I want it to be something else, something make more sense? But yeah. So yeah, so this is the process. It's a lot of talking to yourself, a lot of saying, what do I need? My favorite thing to do, and I'm back in the days when we like went into offices and stuff. There was only one job I ever had in my life where I was designing databases. I had it for about a year and a half, and it was super, super fun. And the workroom we had for the team was, I had them, one wall was whiteboard, like the entire wall from top to bottom was whiteboard. And then I asked them to do the entire room like that in whiteboard. So we had 4 walls of whiteboard. And so with tables and chairs and stuff like that. And so we could like start on one end of the room and just walk all the way around and design the database. Which is really super fun to do that. So whiteboarding is great. So this is my high-tech version of whiteboarding. So, all right. So let's say this is my project. I've got the database done. I like the way it is. This is going to work. I need to get this over into here so I can actually work with it, right? So if I go over to database, I've got something called Forward Engineer. And if I choose that, I don't know if I showed you this guy or not, but if I do, it's a repeat. If not, this is how we learn. We do multiples. That's all fine. I click next. I want to create the foreign keys. I want to create the index names. I want to create everything. I want to create everything I need to do. So click next. And then I want to export all objects, no filters. And then next. And here is the code to create copy clipboard, and you can save it to a file as well. And then I'm gonna go over here. I'm gonna create a new. Yep. And here is my creation of that database. Okay. Oh, the Pokemon database is there. Oh, okay. Does that all make sense for everybody? So now this part is done, right? So I've got the ERD created. I've got the script created. Now I've got to write the code to insert the data. And while I'm doing this, like you saw, I'm coming up with my test cases. And again, a test case in this case is how am I going to allow the end users to use this data? How do I suppose end users are going to come and say, hey, I love this database. Here's what I'd want to know. How many of these recipes use 3 ounces of coconut? And I think I told you that someone, a former student, did something like this, but then attached it to his food storage. Right? So he actually wrote a test case. This dude took forever doing this. He had queries that would say, what can I cook with what I've got in food storage right now? And it would list out the recipes that were available to him based on that. It was a very, very complicated database. I should dig that up and find it. But that's just the power of what can be happening, right? So as you design the database, take the opportunity to say, okay, how are people going to use it? How do I want to showcase this database to people? How do I want people to use the data? What questions are people going to ask? What information they want back out of it, right? All right. Any questions? Because we're at 10:31, and I think we're good for the night. If there are no other questions, everyone good? All right, cool. All right. So then you're in week 5. This, like I said, the quizzes and the exercise all about outer joins. The quiz will have information on. We'll ask about, I think there's one question on accept. Some of you who have taken the week 4 test might have noticed that there is no secret word that I used. That's because I went to do it on Saturday, and about a third of the people had already taken the quiz. So if I change the quiz at that point in time, it kind of breaks the quiz structure. Everyone's got to go and retake it. So I'm going to change the quiz. I'm going to add the question to the quiz tomorrow when I post this. And the word is going to be Albuquerque. I don't know why it's going to be Santa Fe, because Albuquerque is hard to spell. Yeah, I'm in a New Mexico state of mind, so Santa Fe, sure. All right, so that's it. If there are no other questions, comments, thoughts, concerns,
I
um,
have one question.
hit me.
So on the paper that I submitted about doing the database, and you
Yeah, yeah.
said let's see it. And so did you want me to like send you a screenshot of the ERD I already have, or ER?
Oh no, that was just me saying go for it.
Oh, okay.
I watched this dude, Dan McClellan. I don't know if you ever heard of him before, but whenever someone postulates a question, he's like, let's see it. So I just kind of did that. I had just gotten him watching a couple of his videos. So that's what it is. No, that wasn't it. I mean, I do want to see the ERD, but it was kind of my way of saying like, I like this. What was your idea?
It was the for like a airplane private charter type
Oh yeah,
database for like the pilots and stuff.
Yeah. That I think is really cool. That'll be really interesting because you can get a whole because I think you had like plane types and pilot stuff. Yeah, so that'll be a wonderful database. I would say like if you hit that 10 table mark and you start having ideas to get bigger, just stop where you are and then
Yeah, I already hit the 10 table mark, and I think it's good though. So
yeah, absolutely, yeah. All that meant was go for it. I like it.
yeah, I kind of thought, but I wasn't exactly sure.
No, actually, thank you for asking because I find myself, I think we all do when we expose ourselves to a lot of media and we see the same thing over and we start to adopt those phrases into our own lexicon. So I see that. It's like, let's see it, you know. So I have to break myself with that, but anyway, all right, cool. Jacob, Camilla, Nathan, we good?
Yeah.
Excellent. All right. Well, then I'm gonna post this. I'm not gonna post so oh yeah, by the way, just so you know, when I ask you to send me the ERD, I want you to send me a screenshot of this. Please don't send me please don't send me this file here. Don't send me the MWB. I can't open it. I have found students have sent it to me and I've tried to open them. It's like if our versions aren't exactly the same or there's something weird going on, I just can't bring it over, and we don't have the ability to back up databases and restore them in this version. So when I say send me the ERD, I mean take a screenshot of this and send me this. This is all I need to see. I don't need anything other than this here right here. And when I say send me the script, this is what I need here. Use the forward engineering tool and send me this. This is what I need. Because I don't know if I told you this, but I'll say it over and over again. When I grade the final projects, the first thing I do is I look at the ERD and I go, oh, I like that. That's good. Okay, that works. Maybe a little cleaner here, blah, blah, blah. I'll take some notes. And then I'll go and take this code and I'll run it. And I want to see if it works. And if it works, great. If it doesn't work, I take some notes and send it to you. And I see how much effort I need to make it work. And then I run the scripts you have to populate the database. And then I run the scripts you have for your test queries to see if they work, your test cases to see if they work. That's my process of grading. So I don't ever need the database. I don't need you to send me the WMB, send me this thing. Don't send me that. Just send me this. All right. Okay. And with that, I will bid you all a fair good night. Oh, I got some in the chat here. Oh, you got broken microphone. Yeah. This headset is on its last leg. I can't be. I used to be able to be on the other side of the room, but now I've got within 2 feet of the computer at all times. All right, excellent. Have a great week. I will see you next week. Be safe.
All right, see ya.
Bye-bye.